All right, so today we're going to graph, and we're going to do it transformations. So if you're good at transformations, you remember all the transformation stuff, this should go really, really quickly, okay? We're going to start with exponential graphs. We haven't really done much of exponentials, with the exception of talk about how log is inverse of exponential. We're going to graph them. F of x equals b to the x would be a parent function where the exponential function has a base of b. When we have this situation, our parent function key points are always going to be -1 something, 0 something, 1 something. So if I take b to the x and I plug in 0, this middle one, if I plug in 0, what do I get? 1. Every single time, anything to the 0 power is 1. So for every single one of these, we're going to start out with an ordered pair of 0, 1 until we do transformations. Every single one of these, if I plug in 1, what do I get? B. And B just represents whatever your base is. And then if I plug in -1, what's -1 do when it's an exponent? Fraction. It reciprocates. So if it's not a fraction, it will change it into a fraction. It reciprocates. So 1 over B. So those are our key points. There will be asymptotes. We did asymptotes when we did hyperbolas. We really haven't covered much with asymptotes. That's actually one major thing that we're going to do the rest of the year is things with asymptotes. So there's going to be an asymptote, and for the parent function, it will be y equals 0 for the parent function before transformations. So let's say we have an exponential function of f of x equals 5 to the x. Let's see what it would look like. So my y values are going to be 5 to the x. I'm going to use -1, 0, 1. And in my transformation table, I'm going to put y equals 0 just in the y column. Because if I do transformations, it will affect our asymptote as well. So I just plug it in the column too. So I put in -1, and that gives me 1 over 5. I put in 0, I get 1, and I put in 1, and I get 5. So there's the 1 over b, the 1, and the b. So the asymptote will be y equals 0. I'm just going to graph it in a different color because you won't be able to see it otherwise. So asymptotes are that line that the graph's going to get closer and closer and closer to. It's not going to pass it, just going to get closer to it. And then we've got -1 1/5, 0, 1, 1, 5. Hopefully, well, I know you've covered exponential functions before, but hopefully you remember kind of what their shape is. Ugh, which it's hard to do when my computer's up here on this thing. I have to fix it. There. So that is an exponential function. Something else that is in your assignment is we're going to talk about, is it exponential growth or decay? So is this from left to right growing, or from left to right, is it getting smaller? It's growing. This one would be a growth. There's a couple different ways that we're going to look at growth. We can look at growth like how far it is from its asymptote. So this is getting further and further away from that asymptote. And again, it's from left to right the way we read. So that's one way you can look at growth. Another way looking at growth would be if the base is greater than 1, and if the base is between 1 and 0, it would be decay. But then when we start putting in transformations, it might mess things up a little bit. So we'll talk about that when we get to one of those questions. The transformations could mess things up, but this is just kind of basic. So down below, I have blanks. We're just going to write what like +3 on the end of it would do, just transformation wise, just to quickly review that. Does anybody remember what +3 does? It goes up 3. So this is translate up 3 units. This would be translate down. So then the next two, so up and down would be vertical. So the next two have to be horizontal. And I can look at this and tell that it's horizontal because the x plus 5 is in the exponent, and these are called exponential. So if it's inside of the function, it's going to be horizontal. So that's all inside of the function. And remember, when we do horizontal, we do the opposite. So this is going to be translate 5 units left. And then this one will be translate 8 units to the right. And then we've got -5 to the x and 5 to the negative x, where we've got the negative x. One of them's vertical, one of them's horizontal. Do we know which one's horizontal? Marie, which one's horizontal? Are you saying M or N? M as in monkey? That one is not horizontal. But you were correct. This one does reflect in the x-axis. But if you have an x-axis, so I'm pulling out, actually I could do this on here too. Here's an x-axis. If I reflect in the x-axis, what direction am I reflecting? Up and down. So that's actually a vertical reflection, even though we write the words in the x-axis. So anything horizontal is going to be in the exponent. So this is a horizontal transformation or reflection. But then we would write reflect in the y-axis. So if we have the y-axis and we're reflecting left to right, that's the most confusing part. So just to actually graph one of these, how about, I don't know, this h of x, we'll graph that one. Translate down to, remember in our table, if it's something that affects the y's, then we will go and make like a new column in our table. And I'm going to subtract 2 from each of those. So 1/5 minus 2 is going to be negative 1 4/5. And when we do this in a quiz, next class, when we do this in a quiz, you're not going to be able to write -1 4/5. So you just want to make it a mixed number, or I'm sorry, that is a mixed number, an improper fraction, which would be -9/5. No. Yes, -9/5. Sorry, I think. And then take away 2, so -1, take away 2, so 3. And then if I have y = 0 as an asymptote, and I take that asymptote and I subtract, it's going to move down also. So that's one reason why I put the asymptote in the y column, so that I remember to change my asymptote as well. -2, sorry. So then my asymptote would be at y = -2, and all my other points would also move down 2 full points. Question. Okay, so then right here it says, let's review how we find an inverse function. We just did that last class. So if I have f of x equals 5 to the x, to find my inverse, I just change x and y. So I'll have x equals 5 to the y. And then what do I do to get the inverse, like to be y equals? What do I do? Log what base? Base 5 to both sides. So here is my, oh, I didn't write it as a function yet. There's my function, and then my inverse function would be this one here. If I ask you the base for the one in blue, you would tell me the base is 5. If I ask you the base for the one in pink, you would tell me the base is 5. They have the same base. They're inverses of each other. One is exponential, one is logarithmic. They have the same base. Now, another thing that we did when we were graphing inverses forever ago. This is the 5 to the x. Is we graphed them, but we didn't necessarily graph them using the equation. Does anybody remember how else I graphed them, but not using the equation, Christopher? Yeah, we just took our ordered pairs and we took all of our x's and y's and switched them with each other. So that's what I'm going to do with the log. I'm going to use the inverse points, but I'm just going to switch them. But I also have to switch the asymptote. So the asymptote was y equals 0 goes to the other column now. So x equals 0. So to find the inverse of an exponential, we will, or for the graph, for the points, we just switch all of our x's and y's. So when I graph logarithms, which we're going to do real soon, when I graph logarithms, I don't graph them based on the pink one. I graph them based on the blue one. Okay? So everything is based on the blue one. All right, so logarithmic graphs. So everything's going to be x and y switched. So our key points are going to be the -1, the 0, and the 1 are going to be the y values now. And then the 1 over b, the 1, and then the b are going to be the x values now. And our asymptote will be x equals 0 for the parent function. You just have everything switched. So our example graph is going to be what we were just talking about on the previous page, log base 5 of x. So I'm going to plot that one. So my asymptote at x equals 0 is going to be up and down. And then I'm going to have 1/5, -1, 1, 0, and 5, 1. Okay. If you're like waiting for me to go on, the next thing I'm going to do is fill out the transformation. So if you know how to do that already, you can get ahead. Okay, so just to reiterate, you can just graph logarithms, but you're not going to see me do that. You're going to see me find the inverse points and then switch them all. I'll repeat that again when I get to that point. So we look at transformations. The first one, log base 5x plus 3. And then the third one, log base 5x plus 5. Those are different. One of them's up, down. One of them's left, right. How can we tell which one is horizontal? How can we tell? Lainey. It has the parentheses. So you got to be careful, because they look really similar, but the parentheses are what will tell you that that plus what is it? Plus 5 is definitely inside of the logarithm. If there's no parentheses, then you have to assume it is not inside the logarithm. So that means the plus 3 on this one is going to be translate up 3 units. And then the third one will be translate left 5 units. And then with these two, again, we've got the parentheses here telling me that, and you know what? This one doesn't necessarily need parentheses. I think depending on which software or who's typing it up, it could look like this without parentheses, but it's the location of that negative sign. It's not in front of the log. It's after the word log before the X. I don't necessarily need parentheses here. I definitely need them if it's adding or subtracting, but I don't necessarily need the parenthesis here. So this would be a reflect in the y-axis. Then this would be reflect in the x. So I'm going to go through examples. The first 3 that I'm going through are exponential with transformations. If you're like, oh my gosh, I do not need help on that, then you can skip the first 3 and go to 4, 5, and 6 and try it on your own. Or work on your homework with the ones that are exponential and then pay attention when we do logarithmic, or maybe you remember it all. I'm making a video, so I'm going to do all of them. Okay. So number 1, the first thing I do is notice that it's exponential. How do you guys know that number 1's exponential and not logarithmic? As it doesn't have the word log in it. Exactly. That's how you know. So I'm going to start with my table. And my parent function for this one is going to be just 3 to the x. So I put in -1, 0, 1, y equals 0. And then I use my b value, which is 3, to go 1/3, 1, and 3. So there's my parent function. Now I can find my transformations from that. We've got translate 4 units right and 5 units up. So in my table, I will add 4 to the x's, add 5 to the y's. So if I have something like 5 and 1/3, I'm going to need it as 16/3 when we take a quiz and you have to type it in Canvas. So I just keep doing it in the assignment. And then this one will be 6 and this will be 8. I can add a number to 0 and get a different number. So y equals 5 will be my asymptote. Is it growth or decay? Really should have to do with the b value, which is our base 3. That is greater than 1. So that would mean this should be a growth. Asymptote is at y equals 5. Okay, and then I just connect my points, get closer and closer to the asymptote. Domain and range. So domain, remember, is left to right, the x values. These arrows are telling me that it's going forever. left to right. So we're going to have negative infinity to positive infinity. And then for the range, that asymptote is telling me that we don't have all of the y's. The asymptote is telling me that you're going to start at 5 and go above. But will 5 have a bracket or a parenthesis? Do we remember what those mean? Will 5 have a bracket or parenthesis? Barry, do you know? Parenthesis, why? It's not going to cross the asymptote. It's not going to equal the asymptote. It's just getting closer and closer and closer and closer and closer to all the way to negative infinity. Okay, question 2. I'm going to start by writing my parent function table. And I'm going to use 1/2 to the x as my parent function. Okay, I'm going to use 1/2 to the x as my parent function. So I'll do -1, 0, 1, y equals 0. So when I do -1, I am reciprocating 1/2, which is 2, and then 1, and then 1/2. There's reflections in both the x and the y axis. There is a vertical stretch, my factor of 2. And then there's translate, 6 units to the right. I'm waiting for you guys to tell me I'm wrong. Gavin? No, it's to the right. But I was waiting for you to tell me that I'm wrong. So there was this rule when we were graphing a long time ago that in the horizontal transformations, if you have a number in front of the x other than 1, and you have a translation, they can't be in the same parenthesis together. So you have to factor this. And so we would actually have -2 to the 1/2 to the negative parenthesis x minus 6. This is actually the equation that I'm graphing when I use my transformations. So it is 6 to the right. My first spell was like, oh, Miss Crystal, you're wrong, like immediately. You guys were much nicer about it. You're like, Okay. So I'll make my table. And we got to multiply the y's by -2. What happens if I multiply 0 by -2? Still 0? Okay. And then, oh, there's no other column on that one. And then on the x side, we have to multiply by -1 first. And then we will add 6. So my asymptote is y equals 0. Domain is going to be -infinity to positive infinity. And the range is going to go from -infinity up to 0 with a parenthesis. Remember, we always go from lowest least to greatest when we write these. So even though it goes down later, we're going from least to greatest. Oh, I did not answer the question, is it growth or decay? Somebody want to take a stab at it? How many people think it's growth? I'm not going to call on you just because you raise your hand. Nobody thinks it's growth. Okay. How many people think it's decay? Interesting. Who thinks it's decay and would like to explain? Gavin, what do you think?
Base speed is between 0 and 1.
Okay. So nobody thought it was growth. For real? Okay. I feel like you could argue either way. That's why I'm asking. I feel like you could argue either way. I told you to go and like use the base, but really this is getting bigger away from the asymptote. You see that right there? Like, I think you could argue that it is growth. And the reason why you could argue that it is growth is, let's see, this, let me zoom in way up here. I'm going to zoom in right here. What is 1/2 to a negative number? So if I use 2 to the x minus 6, would I get the exact same answer? Would I? No, maybe not. No, maybe. 1/2 to the negative 1 multiplied by 1/2 to the x minus 6. Nope, that's not right. It would be to the, sorry. I'm just using my rules real fast. Yeah, those are equivalent. So I think you can make an argument that this is growth also. If you got rid of that 1/2 to the negative x and you just started with 2 as your base. I didn't, which is why I said it was decay. But I think you could argue, well, this is actually simplifies to just 2 to the x minus 6 and say that's growth now. So I think either answer can be supported and justified. Okay. You just got to be able to argue your way. Question 3 has an E in it. The transformation for this is just translate 3 units down. When I go to make my table, is this exponential or logarithmic? What's E? Exponential or logarithmic? E is the natural base, and you see in there it says e to the x power. That's exponential. What is the log of this exponential? Natural log, ln, right. So this one's not logarithmic, it's exponential. So I'm just going to use e to the x as my base. I'm going to do -1, 0, 1 for my x's, y equals 0 for my y's. Now, we haven't done e to the -1 that I can remember yet, but when you plug it in your calculator and you find e to the -1, it's approximately 0.4. It's actually 0.368, I don't know, something like that, that rounds to 0.4. But 0.4 is what I want you to put down, because how exact am I actually going to be able to plot that point? You think I can plot it to 3 decimals exact? So we'll just use 0.4 on a quiz. If I ask you to fill out a table, you're going to use 0.4. Okay? 1. And then what's E? Oh, nobody remembers. What'd you say? 2.718. How accurate can I be? Graphing it. Let's write 2.7. That's about the closest accuracy I'm going to be, and it's probably barely that. Okay, so that's the points you're going to use if it's E. And then in my table, I'm going to subtract 3. And I can subtract 3 from 0 in my asymptote. So my asymptote is at y equals -3. And then I'm going to plot this quickly. If I'm going too fast with the plotting, I am making a video. Can go get it later. But really, just plotting ordered pairs is not new for us. Oops. Oh, is it growth or decay? Growth. Because E is greater than 1. Okay, question 4. Is this logarithmic or exponential? Logarithmic or exponential? Logarithmic. It doesn't say log, but it says ln, which is natural log. So this is what I do. I first say, oh, that's logarithmic. So in order to fill out a table for logarithmic, I need to know the inverse points. So the inverse of ln is e. We just did this, but that doesn't mean you're going to always have your notes to look at. So I'm going to pretend that we didn't just do this one. And I would write down my points for E. Then I'll come over to my space here. And I will just switch all the points. So I'll have 0.4, 1, 2.7, and x equals 0. And then in the y side, I'll have -1, 0, 1. Now, the reason why I do it this way is because I'm a silly mistake maker. If I do it all in my head starts thinking way too far in advance, and my hand can't keep up. I make total mistakes that way. So I write it down so I don't miss anything. Some of you are really good at doing it in your head. If you just start at the black table, I don't care. I don't care. That's up to you. But this is the way that I do it because you guys know I make silly mistakes. All right, from here we need to do our transformations. And what transformations do we see? There's a reflection in the, which axis? Y, yes, y-axis. And then we've got a translate 3 units, where? Down? Is she right? Yes. Why is it not like left or right? Not in parentheses, exactly. So down is going to be on the y side, and then multiplied by -1 will be on the x side. So when I multiply my asymptote by any number, it doesn't change. X equals 0. So I just plotted the points for my table. The domain goes from left to right. And because we switched, this was an inverse because we switched the x's and y's, the domain and range, they kind of switched too. My asymptote is now a different direction. So it's the x's that it's the domain that has restrictions on it. So this domain is going to be from negative infinity to 0. And then the range is going to be from negative infinity to positive infinity, all real numbers. I'm not going to ask you anything about growth or decay for log. So the next question, I noticed that is logarithms. So I'm going to do my inverse. Oops. And the base of the log is the same as the base of the inverse, 1/3 to the x. So I get my table of 3, 1, 1/3, x equals 0, and then the y's are -1, 0, 1. Transformations, we've got reflect in the y-axis. We've got vertical, stretch, factor of 2, and then we have a horizontal shrink, factor of 1/3. So multiply all my y's by -2, and I'll multiply all my x's by 1/3. Okay, so this one, when I plot my points, it's not giving me a whole lot. If the graph, being accurate on the graph is important to me, if it's important to me, just because I have 3 key points doesn't mean I can't find a 4th one. Okay? It's really what's important to you. And as you guys get into higher and higher level math, you're not going to have your calculator all the time. So I'm going to show like what I would do at this point if I needed to make an accurate graph. Question?
Is it over x, not y?
It's what over x?
The reflection.
Yeah. I don't know why I wrote. Did I say x-axis and write y? Or did I say y? Well, in my head it was x-axis. I guess we could rewind the video and find out, huh? Just kidding. I probably said the wrong thing, but that's what I meant in my head. Okay, so what I'm saying here is with my table, if I feel like I needed another point, maybe I needed -2 for the exponent over here. If I needed a -2, and then that would give me a 9. That way, when I multiply by 1/3, I get a 3 here. And over here, when I multiply by -2, I get a 4. So 3, 4. Just gives me like another point to see where that curve is going. So my domain is going to be 0 to infinity, and then my range will be -infinity to positive infinity. All right, and then the transformations for the, table for the next one, for number 6. I noticed that this one is a base of 2 and it's logarithmic, so I'm going to do an inverse table first with 2 to the x. so that I can make my log table. Transformations, we've got to reflect in the y-axis this time and translate 3 units where? Somebody help me. Translate 3 units to the right. And why is it the right? Because I didn't show my work yet and I should put it in the video. Why? Need to factor out that negative. Oops, which I just didn't do. Need to factor out that negative. So that's the equation we're actually finding the transformations with. See, they're both horizontal transformations. So I'm going to multiply by -1 first. And then add 3. Oh my gosh. So my asymptote is at x equals 3. Got 2.5, -1. Got 2, 0. 1, 1. Domain's going to be -infinity to 3, and range will be -infinity to +infinity.